Welcome to This Explainer. We're diving straight into something that's going to totally flip how you look at your daily grind. We're tracing the incredibly high-tech world of coding, agile, and DevOps all the way back to a pretty unexpected origin, post-war Japanese manufacturing. If you've ever felt like your software projects are just spiraling into chaos, or you're just trying to figure out how the absolute best tech teams operate so smoothly, you're definitely in the right place. Here's our roadmap for today. We're going from factory to code, meeting the 3 M's, breaking down the 7 software wastes, bringing in Agile and DevOps, mastering flow and efficiency, and wrapping up with a culture of learning. Let's get right to it. Section 1, From Factory to Code, Where It All Began. Costs do not exist to be calculated. Costs exist to be reduced. That's Taiichi Ohno, the mastermind behind the Toyota production system. And get this, physical car manufacturing actually laid the absolute groundwork for the digital software development we do today. Wild, right? After World War II, Toyota had to build cars affordably for a tiny market, so relying on the economies of scale from mass production just wasn't going to cut it. Ohno's solution? A relentless philosophy of hunting down and destroying any activity that didn't add value. Basically, if a step doesn't ultimately benefit the customer, it's just waste. So, why should we care about 1950s car manufacturing? Well, think about traditional software development. Honestly, it's usually pure chaos, isn't it? We've all been there. Endless planning phases, sudden bottlenecks, unpredictable crunches, and that absolute mad rush to squash bugs right before launch. Now contrast that with the Toyota production system. It's this smooth, waste-minimizing flow where exactly what is needed gets built exactly when it's needed. The whole point of modern tech methodologies is literally just to take that beautifully smooth factory flow and drag it into our digital world. Section 2. Meet the 3 M's, Muda, Mura, and Muri. Meet our first antagonist, Muda. This translates to pure waste, and in the software world, it's the most obvious bad guy. We're talking about defects, broken builds, or spending weeks rewriting code just because the initial requirements were totally off base. It's a pure, simple loss of time, money, and resources that gives absolutely zero value to the client. You just gotta eliminate it without a second thought. Next up is Mura, which means unevenness or inconsistency. This is the culprit behind those notorious feast and famine cycles we all hate. Picture your classic IT project, right? A super slow start, packed with endless meetings and Gantt charts, followed by a frantic, caffeine-fueled crunch of overtime as the deadline looms. That kind of erratic pacing, it creates massive bottlenecks, and the inability to maintain a steady pace is absolutely disastrous for any organization, which leads us straight to our third M. And that brings us to Muri, which means overburden. Look, when you have wildly uneven workflows, or you're forcing your team to wrestle with terrible tools and zero clear instructions, you're just generating unnecessary stress. Over time, Muri completely burns out your team. And guess what a stressed out, totally exhausted team creates? Yep, more errors, which just means more Muda. It's this incredibly toxic, vicious cycle. Section 3. The 7 software wastes. Factory problems to code. So, Mary and Tom Poppendieck did something absolutely brilliant. They took Toyota's physical manufacturing wastes and mapped them one-to-one straight into software. Take inventory, for example. In a factory, that's just car parts gathering dust in a warehouse. In tech, that's partially done work, like those long-lived code branches just sitting there unmerged. It ties up resources but delivers exactly zero value. Or think about overproduction. In our world, that's feature creep. You know, building those speculative what-if features that customers never actually touch, which just clogs up the code base. Physical defects become software bugs. Waiting on the assembly line becomes waiting around for testing approvals. Once you start looking at software through this lean lens, you're going to start spotting waste absolutely everywhere. Moving into Section 4, Agile and DevOps. Enter. Defeating the 3 M's. Now, Agile and DevOps aren't just fancy corporate buzzwords. They're actual direct countermeasures designed specifically to take down Muda, Mura, and Muri. According to the foundational texts of DevOps, these methodologies are built on something called the 3 ways. The first way is flow, basically moving work smoothly from left to right. The second way is feedback, pushing information back from right to left. And the third way is continual learning. Let's zoom in on that first way for a second. To truly optimize the flow of an idea turning into actual working software, teams use a CI/CD pipeline. Just picture this as our digital assembly line. Code gets integrated frequently, tested automatically, delivered continuously, and sometimes deployed straight to the user without a single human ever touching it. By integrating code daily, sometimes even dozens of times a day, we totally wipe out that inventory waste we just talked about. You kill the chaos of massive merge conflicts and finally get to maintain a steady, highly predictable pace. Section 5. Mastering flow and efficiency, measuring the pipeline. Okay, so here's a totally crucial point. You have to understand what kind of efficiency you're actually after. A lot of traditional managers fall headfirst into the trap of resource efficiency. They want every single developer and tester occupied 100% of the time. But lean thinking, it completely flips the script. It prioritizes flow efficiency. It's not about keeping people busy, it's about how fast a single piece of value can travel from start to finish. If everyone is maxed out at 100% capacity, you're actually just creating massive traffic jams and waiting queues in your system. I know it sounds counterintuitive, but optimizing flow to get software into the customer's hands quickly will always beat just keeping people busy. Which brings us right to how work actually gets assigned. Traditional models rely on push processing. You make this massive, rigid plan up front and just shove tasks onto the team, totally ignoring what their current bandwidth actually looks like. And guess what? That creates overburden, our old friend Murray. Lean and Agile, on the other hand, use pull processing. You only pull a task in when there's actual customer demand for it, and the team genuinely has the capacity to take it on. It's exactly the same concept as Toyota pulling parts just in time for the physical assembly line. So, how do we put this into practice and smooth out all that unevenness, that mora? Well, we implement Kanban boards to make every single piece of work highly visible. We set work in progress, or WIP limits, so developers aren't constantly context switching between 10 different things at once. And we work in small batch sizes instead of pushing those massive, terrifying multi-month releases. Doing this slashes the risk of defects and ensures our digital assembly line keeps humming along without ever getting jammed up. Section 6. A culture of learning, the human element. Remember those 3 ways of DevOps we talked about earlier? Well, the second way is all about fast, constant feedback flowing right back to left. By heavily leaning into monitoring, system dashboards, and actively embedding IT ops directly into daily stand-ups, teams can catch errors instantly. Instead of finding out a feature is totally broken months after you wrote it, you find out in minutes. This immediate, super tight feedback loop stops the waste of defects completely dead in its tracks. And then we have the third way, which really zeroes in on the human element. You absolutely need a high-trust culture. Look, things are going to go wrong. That's just a fact of life. But when they do, modern teams hold blameless postmortems. Like the Google Site Reliability Engineering book perfectly puts it, the cost of failure is education. If you're busy pointing fingers, people are just going to hide their mistakes, and that leads to catastrophic waste on the line. But if you foster real psychological safety and treat every single new feature like an experiment, you completely eliminate the stress of Miri and actually empower your team to innovate. Ultimately, the whole shebang is tied together by the Japanese concept of Kaizen, which simply means change for the better. Because here's the thing, optimizing your software pipeline isn't just some one-time initiative you check off at a quarterly corporate retreat. No way. It's a daily, continuous deconstruction of how you think things should work. It's all about those small, gradual improvements driven by every single person on your team day in and day out. So this brings us to one final, really important thought. I want you to take a hard look at your own workflows tomorrow morning. Look closely at all that unmerged code sitting around, the absolutely unnecessary meetings, the artificially stressful deadlines. Are you actually optimizing the flow of value to your customer, or are you just busy managing the waste of Muda, Mura, and Mori? It's a pretty profound question, right? Answering it honestly is the very first step toward true efficiency. Thanks for joining me on this explainer, and keep learning.